Sorry for that. Myself Sharath Kumar, and we have
Madhurranjan, often called Mamu. And we have a third teammate who's in Chennai partying, but we'd like to mention him, Sudarshan. We have incentives for people who ask good questions, who are attentive. We have like a bunch of t-shirts and books. So if you're attentive, hey, at the end of the session you'll get one.
It's Mamu. Okay, I have to call him Mamu because that's how we call him. It's Mamu's judgment at the end of it. Okay. Before I start, or we start with what we've been thinking of for last couple of months in Apigee, let's quickly look at what we do as Apigee. Can you guys see this? Sorry if we are not able to. We tried something new here, so I took my son's crayons and started drawing actually.
Can you switch off that first one? This one? Yeah.
No, that's full set.
Full set?
Yeah.
No, but they did.
Yeah, without light we are fine. Biggest product which we have in terms of customers and usage. Oh yeah, that helps. Okay, fine. Thanks. So basically this piece what you see here is the runtime, and imagine this backend as any of our customers. Say for example, for all practical purposes, let's take Nike, and this is our data part where we do analytics, and here is our management layer. Now example of this product, how we use, I'll give you a simplest use case. Say for example, you are an mobile app developer and you are a developer for Android as well as iPhone. Now Nike gives you only, their API response is only XML. But for iPhone you want JSON for some reason, and you need to transform. Now you can't ask Nike to put one more for yourself, right? So what we do, we actually orchestrate the whole request to response and we convert that XML to JSON. That's one of it. But we have more like spike arrest, rate limit, and there are more and more of features of this application, which is not important for this conversation. So if anybody wants to know what we exactly do in this product, we'll see after this.
Yeah, quick stats. We run on CentOS plus Amazon Linux. Minimal setup can go anywhere from one machine to we've put in infinity, but currently in production we're around 3,000 machines. We have both a cloud setup on AWS as well as an on-premise setup.
By the way, we host, manage and maintain for our customers as well. This is also deployed on-premise with many of our enterprise customers. So, and just to, what is interesting for this talk is, please look at these open source tools we use. Cassandra, 1, 2, there are 3 places where there's Cassandra, there's Zookeeper, there's LDAP, and all of these are, at the end of the day, they are all web services connected each other, okay? And we have Cupid here, Postgres here, and also a Redshift here, which is not mentioned. And we span in 5 regions. In this example of where we are hosting it in AWS, we span in 5 regions, and we have 5 VPCs connected via VPN, and we have 20 plus subnets to support us, right? Okay, moving forward, given this, please paint this picture so that it will help you to understand.
Yeah. One quick point, pretty much everything is horizontally scalable.
Yeah, the whole of this colors, whatever they are all scalable. And what are we trying to solve? I think this is the 4th DevOps Days where we are here together. I think all 3 DevOps Days we have found this problem, right? Okay, we have a very different environment for dev, it's handcrafted, we have a QA, it is automated with Ant, Java or something, and there is this perf environment, we don't know, there's some other team which is deploying it and managing, and this is production managed by our ops. Oh, they have tools, MCO, Puppet, EM, Hira, manual orchestration for deployment, but there is Sumo Logic, Nagios, Graphite. But this is what we have been talking about the problem, right? There's no big thing. But we also encountered the same problem. When we started a couple of months back, we also saw the same thing. Now, it was easy for us to talk about, okay, let's automate everything. Let's put tools in place. Let's make, part to production unique, streamlined way, etc. But what we did actually, we thought one level above, and we said, what is the end goal of any organization where we want to go? So basically, it's a self-service. Imagine a world where anybody, so if you think this as an ecosystem of Apigee product, imagine you are able to get this ecosystem on the fly, on demand, without any effort and in quickest possible time. So we said, okay, let's do this. So let's go to the self-service model. Now, self-service model also needs to support multiple of our requirements. So our requirements were like this: to standardize and self-serve the entire RPG ecosystem with the minimal effort and time. And then to have a single toolkit, because a developer needed an ecosystem to test, a test group required, this is all internal, right? Test group required the ecosystem to test for some environments and other environments. Then we had customers, on-premise and salespeople, pre-sales people. And we couldn't have different technologies and different tool set, because even though we were doing everything similar, same configuration, same OS, but different tool set doesn't scale, or it's hard to maintain. So we said we need to have a same toolkit. Then we said reuse the same solution wherever RPG ecosystem is needed, like laptop, cloud, on-premise, private cloud. That means whatever we build, it should be the same tool to develop the ecosystem. And usable by developer, test teams, pre-sales, sales, customers by themselves. That means simplicity. We wanted to get to that simple level where ideally one particular input and you're done.
Yeah, just a quick thing. So the first time we had like release version 1.0, and we gave it a pre-sales guy who was going to the customer to demo it, and he tried a couple of commands, it did not work, and he said, dude, what the hell is this? I mean, so basically for somebody who's non-technical, it has to be super simple. One command and maybe, okay, he goes and gets coffee or whatever, and then everything should be up and running. There's no patience, no technical stuff. Don't talk to him about that.
And it is not an internal tool. I am not saying we don't take internal tools seriously, but yeah, internal tool, there are some glitches and glitches, that's okay. But because we were targeting every kind of user, including customer, this has to be super cool and super easy and reliable at any given point of time. And because of the scalability, one machine to N, that's added more complexity to it. Okay, so then we said, okay, what does this mean to get there, right? So if you really look at, our idea was to get the input for the planet, the whole, what should be a planet look like?
So planet is our internal code word for environment. So our production is called Earth, staging is called Mars. Sort of funky, but yeah.
So basically the entire ecosystem, if you want to, because it's configurable in terms of the network, in terms of the scale, etc., we said, okay, we have to gather that info for sure. Without that, we can't do anything. So let's gather that. After that, we have to create the network based on the info and the context of RPG software, because service 1 has to be here, service 2 has to be here, service 2 talk to service 3, etc., and Cassandra has to be here, things like that. With that context, we needed to build the network and subnet, then create machines and configure them. And then we showed you all the third-party applications we use. So we wanted to deploy and configure. Then we had our platform, which we showed you in that first diagram. We wanted our platform to be deployed and configured. Wire them, configure them, because the interconnectivity of the application is also important to get it going. And deploy RPG application. The complexity with RPG platform is one set. There is another set of RPG applications that sit on top of this platform to make it work.
The example being, so when customers deploy their rules, right, like convert from JSON to XML or to rate limiting. So those are all what we call as customer bundles. So when we deploy application and we want to test for a customer, we also have to deploy those on top of it.
And obviously this is a environment created with seriousness, so we needed logging and monitoring on top of this. So this has to be added to their central monitoring and logging so that it's available just as another environment. And then we wanted to verify all that what we spawned off and wired, everything works as required, and test it, right? And notify the user only with the URLs, no other details. So idea here is to collect the data, notify with everything up and running with the way a customer wanted. A customer can be a developer to the real customer, okay? So what we have after a couple of months, we have two commands. The first command, sorry for not highlighting this, this is create profile. Basically, during that create profile, he says, okay, what's my provider? Whether it's AWS, VirtualBox, OpenStack, what it is. And then how many regions, how many machines, how many Cassandra nodes in the ring, how many Zookeeper in a cluster, what LDAP, is it in one box, is it in n number of boxes, how many VPCs we need, how many subnets we need. So basically it's network architecture, everything. Basically these are simple questions we ask. I think 20 plus questions, Mamu, if it is correct, yeah. 20 plus questions. After that, he says auto setup and puts his profile file there. Basically, when he creates a profile, he gives the name of the profile, which is foo, which is our planet name, and you say foo, and then that's it. And we'll come back to this. So out of only we have 2 commands now. And what happens? So those 2 commands, what they really did was, this was static, okay? Internal Git of a company, and we had our Jenkins, where we had all our artifacts generated, the builds, configs, and the DB.
Are the 20 questions also asked to a pre-sales guy?
Yeah, which he'll know, because if he's creating, right, whether it is laptop or AWS.
Yeah,
it can't ask technical in terms of, do you want it in availability zone 3 of this? No. It will ask, okay, how many availability zones? Do you want it to be resilient?
There are always defaults for it. And the thing is, once he creates a profile, the profile sort of persisted. So next time he can have, like, say, a pre-sale profile with these components. So next time it's like a one-time creation of the
profile. It's a persistent profile, anyway. Right? So we had a machine in cloud. Okay, I'm going to give you an example of AWS now. A provider is equal to AWS. We had all the things, DB, config, everything coming from here. And we had a software bank. Basically, instead of downloading Cassandra every time from the Cassandra side, we had our FTPs kind of a site. And once we added that 2 command, this is what we got. We had entire startup from bottom, creating VPCs, subnets, connecting them via VPNs. We use Viata and BGP. And then we have machine subnets, connections, added them to Nagios, Sumo Logic, ultimately created these 3 URLs. Basically, one for runtime, one for management, and one for our UI. We added all these entries in Route 53. So this took us, like, our 40 machine takes us around 10-15 minutes, and we are improvising on top of it.
Our biggest testers were our regression team. So previously they used to hanker around, hey, give me these machines to test and so on. Now with 70 odd machines, they bring it up in roughly around 15 minutes and test it, run the regression for an hour and a half, and then machines go down.
Yeah, 1 second.
So this is in case of AWS. In case you have machines at home, maybe in your office.
Yeah.
So do you create VPCs and VPNs
Okay.
there as well?
No, there we say, okay, basically in the on-premise, actually we create not VPCs, we create different subnets if required.
Okay.
So it depends on what you want. So the context of the application, which is Apigee application, what in a virtual box, single machine, you can't create multiple, subnets and other stuff. So that context is known to us. We will come back to that in a minute. If it is not clear at the end of it, I'm happy to answer that.
And the bit is not exactly complete. So for an on-premise solution, we're still building it. But yeah, eventually aim is to have it across OpenStack and just hardware machines and stuff.
So my assumption is you run these 2 commands even to spin up your production machines, like production side.
That is the idea, but currently we have moved up to stage. Like yesterday we used this for our staging environment. So eventually, yes.
Okay, so when I used few other systems, I see there are 2 options. So you asked the question like which cloud you want to like spin up the machines, AWS or vSphere or OpenStack or anything else. So do we have any options like optimized or reliability? Say something if a customer wants cost beneficial, so he can spin up the machines in a few different clouds, then he can spin up the machines and he can network them to.
When you say a few different clouds, what would
like AWS, I run these servers in AWS, these in vSphere.
No, currently we have not, but a very good point. We will take that up. Maybe for next year's
I have
DevOps.
seen few systems.
Maybe for the next DevOps. Thanks for that. Any other guys? I think anybody had a question? No. Okay, fine. So let's move on, right? So I created this. But imagine, right? This is applicable for a developer. This is applicable for any of the user. Now the benefit is we had so many open source tools like Cassandra 1.2, 1.1.12 we were using a few weeks back, and all of a sudden we wanted to move to 1.2. And imagine you taking a downtime of your existing environment or trying to upgrade, then trying to fix, then trying to test. Rather, it was one simple value, which value he will tell you in a couple of minutes. One simple value change, spin up the entire planet in 20 minutes, test it in 15 minutes, go back to development team and say this doesn't work, right? So there were enough use cases which we solved. Not that we thought of everything. When we started, we didn't think of all the use cases. As it evolved, we were writing the manifest.
Yeah, and even now I don't think we've covered everything, but it's obviously an iterative process.
Okay, this is all very simple, nothing new, right? Building an environment and things like that. But I think, given our requirements and the life cycle we had and the complexity of application, getting that one tool set applicable to everybody, that was an important thing. So we will go more. Now, this was all about use case and business justification. Now we'll go how we really did it.
Okay, so the create profile that you looked at, we generated out a YAML file. Then, so the thing is, we started with Vagrant for VirtualBox. As most of you would have done yesterday, there was also a demo with Salt. So you start with VirtualBox, see how you can set up your entire environment in a single box. Or if you have like an 8 GB box, you can set up 3 VMs and have multiple things around it. Then what we started doing is, hey, can we do something like this even on AWS? Can we use Vagrant? So at that time, what we saw was there were people already who were using things like Vagrant on AWS. So the main guy, he himself has written a plugin called Vagrant AWS. There's also somebody who's written Vagrant OpenStack and so on. So we started to look at Vagrant AWS. So obviously the thing that you would notice with the Vagrant file is, hey, how do you write so much of stuff in a Vagrant file? But if you spend a day or two, you can actually have scripts or whatever which will generate out a Vagrant file. So you take a YAML and spit out a Vagrant file. So that's one of the first things we did. And Vagrant is really cool in the sense that the same configuration that you would run on development, you'll run in AWS as well. The only thing that will change is the provider bit. So Vagrant has this concept of provider. My default provider is VirtualBox. And then on AWS, it's AWS. Tomorrow, if you just have pure hardware, it's just hardware. And you can create your own providers and so on. And it also allows you to have multiple provisioners. Our provisioner is Puppet in this case. We'll just talk about how you use Puppet. So if you're using Chef or Salt, yeah, just plug it in. The other thing that really helped us is it gives you a great ecosystem of writing plugins. So you can write pretty much any damn plugin you want to test whatever you're doing. So we'll talk a little bit about that. So we generate Vagrant file, then we spawn off machines. So initially, so as part of this, we contributed quite a bit to Vagrant AWS. We wrote tons of our plugins. Some of them, once we feel they're stable, we'll open source it out. So everything, the machines used to come up in serial. So it means 10 machines, each machine takes 2 minutes, 20 minutes gone. So we work with them to make sure that we spawn off n number of threads. So we found that on a medium machine that we use as an orchestrator, we can run up to 12 AWS threads at a time to spin up machines. 13, 14, there's various cases with timeouts that you have to play around, and the CPU will hit a point and some thread gets killed. So we spawn 12 machines at a time if it's a 70 machine node. Then we also, so things like provisioning, right? So when I say Vagrant provision, it will use the configuration that you have in your Vagrant file, let's say Puppet, and it will start running. That is also serial. So what we did was, we did not have, we do have some sort of dependency that, hey, first provision A, then provision B, then provision C. But we found a way wherein we can run all provisionings together. So we used parallel gem that Ruby has, very cool gem. It will just allow you to simply parallelize. Or there's also a GNU package that you can use. It's the same name. We were writing everything in Ruby, so we said, okay, let's use that. Yeah, so we bring up machines and then install applications. So Puppet uses something called as Hira. It's written by the same guy who used, who wrote M Collective. What it is essentially is like a hierarchical data store. And then what it allows you to do is you can specify RPM URL for one of the applications. And then if I want, so we have multiple components. So let's say machine 1, machine 2, machine 3. Now there are cases where machine 2 has to have a different RPM just for testing case, and machine 1 has to have different RPM. So Hira is something that allows you to do those kind of things. The other thing that Hira allows us to do is, let's say the developer has spawned off an entire environment of, let's say, 15 machines. And now he wants to say, hey, I tested it with this version, which is in production. Now I want to test it with this version. So all you have to do is change it and then run /auto setup provision on that planet, and it just brings it up.
Basically what we are saying is once we provision, right, then you want to modify anything. Say for example, you have put FPG RPM as 1.0.3. Now you want to put 104. You don't have to nuke and create something new. You can actually go to the Hira variable and change that version and say vagrant provision. So it will again go back to that machine and do it. Yeah.
So if a dev spawns like 20 machines for his development environment, you create a VPN between his own system and so that he can enter into that?
No. So his access is via the the orchestration machine or the jump host machine which we create. But only the VPN is only between the different VPCs if he has asked for.
Isn't it a bit tedious for the dev to get into another network and then work?
No. So even in regular day-to-day work, they do get into a jump box and then go somewhere else. So getting into one jump box and running a command. But anyway, we are sort of integrating it with Jenkins and probably our own tool. So that will be sort of something.
And also we are trying to make use of one of the services from Amazon to drop their network to our network and give us a entry point from here. So that's still in progress. So once that happens, then we'll have access from our entire network.
And what we do is we create user-specific jump boxes or have same boxes create multiple accounts. I mean, you can do multiple things to map. What we do though is every week we sort of find out, hey, how many planets are running per team, and we sort of send it to her. It is definitely better than, for example, having 4 static planets, which is what we still have, but we're slowly removing it. One second. So instead of having 4 static planets, let's say one planet consisting 10 machines, another 50, another 100, which are on 24/7 for, like say, 2 years, 3 years, it's sort of better to do this. The other quick point that I want to bring out is, since we have multiple product teams inside, testing integration between 2 products will become a pain if I have the same 4 static planets, because if team 1 is deployed on it, then they don't have to wait for team 2, team 3 to do it.
What he's actually saying is, we don't have, so we have, okay, sorry, we did have all the static planets like the pre-prod, UAT, stage, etc., blah and blah. Our first primary focus was to get away from all of this. Basically don't have planets static, because one, cost and other stuff. Second thing is then there is maintenance of the planets. We'll come back to this again. But the idea was to be on demand, self-serve to entire group, as within as well as outside.
Okay. Next thing with Puppet provisioning itself. So we run a huge number of Puppet servers in production. Beyond a certain scale, there are issues, etc. So what we wanted to do is get away from Puppet server, and so we use Puppet headless. So a guy called Jordan Sissel, who's written Logstash, he has a beautiful blog on how to do factor-based Puppet, and tons of people have actually used this. So what it essentially do, so Puppet comes with something called as factor. You set factor variables. So a simple example being an application. Okay, it's the equivalent of OHI in Chef, by the way. So let's say a machine comes up and you associate a factor called application is equal to, let's say, zookeeper. So you have a single truth enforcer, as that guy calls it, or a file wherein it goes and checks, hey, it goes and checks against the factors and then decides which class or which manifest, etc.
Yeah, can I oversimplify this? Excuse me for this. So basically it's like an environment.
No, you can't oversimplify.
It's like an environment variable. Each machine has got an identifier, and you say, do this action in this machine which has the identifier is equal to. That's
yeah, and the other thing that we have is we generate out an application.json file at the end of it. It's super helpful, because as we bring out machines, we also use mcollective to figure out, let's say, hey, find out all machines which are running Zookeeper, or find out all applications which are, or machines in this network which are running, let's say, some application foo. But when you're still bringing up machines, it's very difficult to do that. So we generate this metadata sort of JSON that we query. That also helps us when we are creating at the end of it like ELBs and associate Route 53 entries with all these kind of things. So somebody who wants to do it, I would strongly recommend them to get some sort of a JSON YAML, whatever you like, which gives you metadata about this. At the end of it, okay, how do we get Puppet into the machine? So you can either have it as part of your AMI itself, or as part of user data that AWS gives you, you can associate it. The other thing that we do, okay, I was talking about Vagrant plugins. So let's say all the machines are up, you've run Puppet on it. Now is the time where we run a bunch of API calls. So things like service discovery. So we use Zookeeper for it, like most people do. So each machine sort of has to call a particular API, make a REST call, and register themselves and so on. So we use Vagrant heavily for it. So I can say Vagrant APG, name of the component, and register. So it'll pick up either from MCO or the application JSON, and then go and register with it. So that's one of the first things.
So basically, these are all API calls which were supposed to happen. Like once you have all the machines up, all the applications are deployed. Basically, go to each machine and register itself as a component and do this. Basically, that's all those are API calls. Basically, we wrote a plugin to make those things.
Yeah, this is it.
So this is the same auto setup command again.
Yeah, so we've sort of covered this. Vagrant provides instances by picking up API providers. Yeah, so we've written quite a few plugins, etc., to do the ELB bit and Route 53 setups. All of these are API calls. The other things we do is you can sort of build, like you do in software, right? Build basic plugins and build more plugins on top of it, which call all these basic plugins. Okay, next slide. Okay, this is a simple plugin that we have written for ELB. So Vagrant ELB, and these are your options. So internally from another plugin, we sort of call this and set up things.
So we don't have to. Basically, this whole idea is coming here with this one Vagrant and all the plugins, everything, because we wanted one way to create anything and everything, right? So the way we use Puppet.
Yeah, sort of spoken again. No centralized Puppet Master. I would strongly recommend any of you to not use Puppet Master. The way is to populate PuppetDB if you are using it, or you can get your Puppet statuses into Graphite by different ways. But yeah, after a particular level, it becomes a little bit of a. Yeah, so we basically check out manifests. Every machine will run one common manifest, and from there it sort of branches out into different ones. We have a small example, I think. So this is an example for a Zookeeper one since we've been speaking. So we have application JSON, and then we parse it out. Puppet gives you the only way you can write Ruby code is through parser functions in Puppet. So we have some way which loads the JSON. So on the machine, if you say if this has application Zookeeper, if it's a Zookeeper machine, then go ahead and run Zookeeper. The other thing that we found which was really useful and which was not there earlier is make sure that you follow the same pattern across all your Puppet manifests. So if we found having a class and passing parameters to it was really, really useful. You can do a whole bunch of inheritance, but do all your requires and inherits in the manifests, but have a clean call from outside. Have defaults, etc.
So this is the one more thing.
So we, at the end of it, we sort of run Vagrant APG status, and it gives us all our components, which ports they're listening, are they up, down, so a quick way of testing it, yes.
Yeah, the approach that you showed a while back, so if any, while creating all the nodes, right, if any error occurs, is it only that, will the whole process stop, or how does it go?
Yeah, different ways of handling that. Currently, we go ahead and spin up other machines and then say that this is failed. But the last step that we're talking about API registration, that will fail depending on which machine came up or did not come up. So if it's a core machine, which is dependent like a management layer, that doesn't come up, nothing else will come up. And we've actually found like 6 bugs in the last 1 week alone because there have been issues with some application at the management layer. Yeah, so if it's a more peripheral application and that doesn't come up, we are fine. I mean, only that component will not work. But if the main component doesn't come, hey. And the thing is, we sort of deploy the same RPM across the whole place. So we do find different things.
Yeah. So
From the user
basically,
perspective, only this is the one where you come to know which is passed or not, right?
No. At Puppet layer, at the provisioning layer, we do get notification. This is right at the end. When everything goes through, then you want to know, hey, what happened? Or let's say I want to update the URL and deploy. So the machines are up. I just want to change my URL. Right?
This is not only at the end, right? At any given point of time, when you have created a plan, you're running you're going through fine, and you see some problem. You want to see if any of the services are down, whatever. This is any time.
At any time you can run this.
You can run this.
As an end user, he finds it easier to
This
say,
is like one
vagrant
command for
distance.
you to look at the status of the entire planet, the whole environment. So on top of this, we can build monitoring. There are various ways we can handle these things, right?
Just go back to the slide. Yeah, you mentioned that you can run the script and build the whole planet. But for example, I have 2-3 planets already. I don't want a new LDEP for the, so I can just can we split it up and use some of this and build a new one.
Like update of the infrastructure?
So update existing planet with one of the mission types, with one of the things is possible, not a problem. But reusing from one place to another is not yet what we are thinking of. But you have a planet today with say 5 of service 1, 5 of service B. You want to add 2 more to service A, you could do that. That's possible. That granularity is given. Granularity at the application level and the node level is given, but it's not at you reusing from somewhere else to this, not at that point. Okay. That answers your question, I hope. Yes.
Generally, backend runs on top of another level.
Vagrant also.
Correct.
Then how to doing in AWS?
We run it from a jump box.
That's what the orchestrator machine we showed, right? That's a CentOS machine.
Anyway, if you use a VPC, which is what we use, you need some jump box or whatever from where you can connect to private and public subnets.
Okay, in that centralized machine you are running Vagrant.
No, only on the jump box we run Vagrant.
Oh yeah, correct. Your question is, do we run Vagrant on that CentOS machine? Yes, we do.
The jump host.
One second, sir.
In that case, that already AWS is running its own hypervisor. Like again, creating OS on that hypervisor.
No, what is the OS?
Vagrant, okay, can we take this after this conversation?
Vagrant is not the OS.
Okay, let's talk about it.
Okay, so see, I understand if it is for multiple environments, like you have a plate server and you have an Amazon, or suppose I'm working only on Amazon, I'm working only purely on that. So we have a cloud formation there. So what is the advantage if I want to use this or that?
Yeah, so things like the whole registration bit that we spoke about, that's something that we initially it was tried and we were not able to do.
Yeah.
You want to
the FPG context, right? The whole application context is missing in your cloud formation. I can't put my FPG software has to be like this. These are the components. This is how it connects. This is the VPC. So we never ask, what kind of VPCs? We know that our management server has to be in some place. We know that our messaging layer has to be in some secured location. So it has to have this kind of ports open. The security groups, all that is FPG context for us.
But most important is the service discovery, the API calls that we make at the end. We did not want it to do it as well.
For the specific, what you mentioned was VPC and all, that can be done through cloud formation.
That can be done, but the main bit is the whole API calls.
Yeah,
so
even templates you're talking about.
So prior to this, the ops guys used to run a couple of shell scripts at the end to do it. But what we said, okay, just use this too.
But the cloud formation also nowadays allows you to do the same through the template. So you can embed that part and does the configuration.
No, but yeah, this is because we want the same thing to be used in AWS, OpenStack, Vagrant, blah blah blah.
No, one is that. Second thing is, we can because we are running.
Sort of. Let's take this off.
Because there is a FPG context which we want to add. Because for that you need to get the whole FPG thing what we are trying to do. Sorry about that, but we'll come back to it. Okay. So this is exactly the same thing. Okay, go ahead.
Okay, so obviously you would be wondering, hey, where the hell are you testing things, right? So this is where, okay. So this simple, I picked up a few tests from it. We use server spec to test, and we've also written a few things there to add curl and stuff which server spec does not have. We'll submit it as a patch. So at the end of it, you can run Vagrant FPG test or just straight server spec or whatever, and it'll go across all the planet, all the machines and run tests, etc. So server spec is a cool way of testing if you're using Puppet. I spoke to a couple of people who are already doing it. So if you want to have more details or whatever, you can look at server spec and I can talk to you about it.
So this is the testing of the planet which we created for its functionality kind of a stuff. Right? So in conclusion, we want to say that we actually achieved one way of creating FPG ecosystem, be it with developer, laptop, test environment, cloud. From the user perspective and from the provider perspective, we have one way of creating. This is the matching. This is basically accomplishing the first requirement we had in the previous slide, right? But we feel this is just the start because we need to go and get self-healed and self-scaled. Like for example, when something goes wrong, if a planet can identify itself that I'm running in a degraded state, and if it can heal itself, that's the next step what we are going for. And the scale part, right? Like you are saying, reuse of multiple planets. So that's the next part which we are saying. And also we will have, I think we will also get to multiple issues and problems when we want to scale to 2,000, 3,000 machines to replace our production. So that's something we are looking for anyway. And in terms of the packaging, I think what we have today is one package getting there and getting started as multiple provide. I think from the build and packaging perspective, we need to have componentized packages so that we can target the deployments and target to support our autos, heal and scale part. And also the staggered deployment, because if you know that a set of things is going bad in one planet, how do we actually replace them one by one? So that's the staggered deployment which we need to talk. And also version 1 and version 2. We said you can change the Hydra value, change application version or component version from this to that. But we have to see how we run A and B kind of scenarios so that we can do more of zero downtime deployments. And yeah, obviously this simplified our path to production because starting from developer to testers to on-premise sales, pre-sales, nobody today shouldn't talk about, oh, my environment not there, there is a date conflict between that team testing this, we are testing this. Also, we showed you a lot of open source components like Zookeeper, Cassandra, and they keep changing, releasing patches, etc. to test them. We don't have to get to an environment to test them because we can change the Hydra variable, get the software into SoftBank, spawn up the new planet, test it in like 15-20 minutes, you know the first signs of it, right? You don't have to wait for somebody, you don't have to worry about. So that's simplification of path to production. I think this was given for us when we actually started. Okay.
Okay, well, apart from the fact that we wanted to give a funky name so that our dog gets selected, and Sharath is walking away, we also have a message that make sure we plant trees, etc. Okay, can you go to the next slide? I have a few points there.
Yeah, I'll go there. Yeah, so any thoughts why this is green? Our name was environments and green.
Apart from all that I've mentioned.
Yeah, yeah. Oh, you did the tree thing already, yeah.
I was going to ask you that. What's the green part?
Cool.
Yeah, font.
The color.
Okay, so basically the green part is what we have seen, and we have also seen, I think both of us were in our previous avatars, we were with ThoughtWorks and we were consulting, we have seen with multiple of our customers, as well within Apigee itself, that after the migration happens from on-premise to cloud, basically what we do is we create static environments and we keep it there. Like come Saturday, Sunday, you'll be seeing some static environments up and running because not it's completely automated. To handcraft it on a Monday, it takes time, etc. and etc. So we waste a lot of money, resources, etc. So this is on demand. So that's green part of it. And there is nothing called maintaining infrastructure. And in our traditional days, we had a lot of tickets to our ops team where, hey, fix this LDAP. I think LDAP service is not coming up. Yeah, but there is a very thin line between when do we really, for every problem, start recreating planets and where we start digging into the problem. So there's a thin line because you might be having a real issue with your software. After 8 hours, it might be degrading. Solution is not to kill everything and start building new. But there's a thin line. But go ahead.
I just remembered another reason which we've not put in. So in our previous organization, green is actually a color of success. Green builds, green environments.
Yeah.
Green when you deploy, you want it green.
I have it.
Oh, you have it? Okay.
Basically, at any given point of time, your environment, application testing, ecosystem, or for a sales, pre-sales guy. Like I knew when I joined Apigee, if there is a demo with tier 1 customer, like that environment, there are at least 4 or 5 guys guarding that environment for next 1 hour, right? Now you don't have to because you can create your own and be happy with it. Yeah. Do the demo. And no waiting, dependency, wasting time in setup, upgrade. So productivity is green. Path to production is uniform for code, config, DB. So bug count at production should be green, no manual errors, etc. Yeah, so like he found out one, which I didn't add, sorry.
I knew you did that, that's why.
Yeah, so the list keeps growing, but that's just to feel good about it. I'll come back to it. Just to feel good about it. But we know that this is just the start, and there's so much more to do in this space for us.
We have another four minutes for questions. Yes.
So the question was like, so you are creating the machines as of now using the script. So do you have any release script? Say sales guy shows the demo to the customer. The next minute he doesn't want to run those machines. He just wants.
Oh, sorry, we missed it.
Destroy. So we also have a single one-line command. So you say /auto setup.
Yeah. Auto
planet
setup
would destroy.
Yeah, destroy. Yeah, auto setup destroy. It automatically destroys. Yeah. So when I said okay, this is because we have 4 minutes. Let me give you what my thoughts around this. So much more to do. The immediate thing we need to do is basically look at one. Basically, take a parameter for how many hours you need a planet, right? And after, if you say I need it for 4 hours, after 3.5 hours, it sends an email. Do you want to continue or kill? And that's a real optimization, right? So we do have that capability. So that's what we are looking at. So much more to do is all in this angle.
I guess for short-term environments, you can use spot instances and stuff like that.
Correct,
Yeah,
right?
absolutely.
There are too many of those which we need to add, right? And we want to write more provider plugins for various things which are not there for Vagrant and open source.
The common theme that we were talking about, failure Fridays, game days, that's something that is not there right now, but yeah, we want to play around and get that. Spot it.
Does it accommodate existing data in the sense you can destroy an environment, back up the data first, and then bring it up back, right?
Not at this point of time, sorry. But yeah, so
unless you have that bit completely on ELB, take snapshot and stuff.
Yeah, basically keep a ELB and other stuff like that.
One question on the use of ELB. I see 3 reasons why I could not use ELB and we replaced load balancers from ELB to Nginx plus SC proxy. Okay. The first reason is if I want to block certain IP ranges from making a toss attack on my service, that is not possible with an ELB. Second reason, a round robin load balancing policy doesn't work in some cases. Third reason is EIP cannot be associated with an ELB, so it stops us from doing blue-green deployments. So how do you deal with these challenges?
Okay, this is something that maybe the ops guys can actually answer. The third point about elastic IPs being different. So currently we still do, so we have multiple layers, management layer and other layers. So we can still deploy to one environment only. So we're more looking at sort of staggered deployments once it comes to production rather than a blue-green. But yeah, I'm sure once we go there, we'll hit these problems.
Yeah, one and second thing is this blue-green deployment is into our application architecture as well, because you have multiple of these, right? So you might, in our routing layer, we might have multiple machines. We can have multiple on the messaging. So what we might do is we want to flip. There are mechanisms within application which you can switch off and stop, serving traffic and things like that. So maybe because we are not thinking about that right now, maybe because of that. But those are really things.
Second question is about Redshift. Why do you use Redshift?
Can you take it after the song? Sure. There's a guy standing on the third. Yeah. There is Raghu who is part of our group again. So we'll talk about it.
Yes.
Somebody else.
How do you, can you shed some light, how do you do it on premise? I mean, when you already have a network set in, you don't have, you might or might not have subnets there. So do you first?
Yeah, by default it's just plain just IPs, and you get a list of IPs and make sure you have the same SSH keys and go and log in and stuff till you have that. And some of our customers do not allow us to download stuff from outside. So they have like Yum servers are all within. We even put the RPMs etc. or tar GZs within the package so that you can just copy it from there or sync it out.
That's almost an evolving phase for us at this point of time.
So the way we do on-prem is make sure we get this information. There's a separate UI that we are sort of linking to. The guys who go to do an on-prem, they get this questionnaire or whatever for the customer to fill up and blah blah blah, and it's a UI thing that saves it into a YAML and then.
Do you do any bit to help those guys out? Maybe scale them out.
Yeah.
Do you do any bit to scale them out, or do you give your requirements? I need these number of IPs to do this.
Yes, yes. So on-prem, there is the packages from 1 machine deployment, 3 machine, 5 machine, 9 machine, 18 machine, multiple data center.
Right.
So depending on the size of the customer, they pick any of these packages, and obviously costs will go based on that.
Right.
Yeah.
The topology is kind of.
Yeah, so you don't control the topology.
No, we don't.
Because that's how customers.
Obviously, we have best practices.
Right.
But how they want to do it is dependent on.
So as of now, I see you are spinning up the machines in your own AWS account or vSphere account. So is there any option for customer so they can specify their own account and they can maintain?
Yeah. So the idea is to make this self-serve to that level. Like today, we host and maintain, right? The idea is because this is a parameter for us. Our AWS credentials and other things are parameter for us. Tomorrow, if somebody wants and says, "I want to have my own," yes, why not? But we haven't yet gone there, but that's the long run goal.
Maybe 2-3 months from now, we'll have customers also using this to test this internally for at least for the on-prem guys.
We might have this as a service itself, who knows, we don't know. So we are still evolving on that. Because we started solving something different and where we are, and we see the opportunities, right? Yeah. It's way too different.
How you detect degraded performance in your application? Which parameter you decide the performance degraded?
Okay, that's the whole monitoring aspect. Can we take it offline? We have some thoughts on it. We also have one of our core testers here. He can give you more information on this.
One is that
Raghu, can you just stand up? Can you just
Raghu, just stand up.
Yeah. Why don't you talk to him after this? He'll give you more.
Another thing is we have some app parameters in terms of messages, message drops, and how much is coming to data. We do have our own analytics piece, which I showed, right? So we also make this decision based on that. So not everything is.
There are no more questions. Yeah.
I'm interested in knowing how you made those slide diagrams. You're saying something about crayons.
Oh my God. Okay. So should I break it? Yeah. It's not a patentable, so it's fine. I'll show you what I did. So basically, what happened was I was really feeling bored to draw a PPT, and then I took my son's crayon and I said we had a big fight, and then I took the crayon, I drew this, and all that you see in this, whatever this color is, I don't know what this to say this, fluorescently bluish thing. So I wrote it in red pen. And then imported to Picasa, then said invert colors. So all the colors you see there, that's a black, which looks like a chalk piece. So basically inverted the color and it gave me this.
Please quote us when you're using the same technique to present something.
Yeah, me and Mamu were trying to patent this, but Ajay, any comments?
Okay, the guys who have asked questions, we are done with questions. We have some goodies for you. And we have some more goodies for everyone else. So yeah, maybe if you could come here or if you ask intelligent questions or whatever, and we'll give you.